On this F150 with the 2.7 EcoBoost, P0171 means the engine computer may be seeing a lean condition on bank 1. The truck may have a rough idle, hesitation, reduced power, hard starting, or it may just have the light on with no obvious drivability complaint. Broadly, this can point toward possible unmetered air, intake or vacuum leaks, fuel quality or fuel delivery concerns, exhaust issues, or sensor and circuit inputs that are steering fuel control the wrong way. For this diagnostic path, do not treat P0171 as a parts call. Start with the basic system checks. Confirm the concern is actually present, and if it is not present, do not replace modules or other components just because the code was stored. Before going into detailed testing, look for the obvious concern that matches the customer symptom. Check for any related OASIS or TSB information if available, and look over previous repairs for anything that may have been completed incorrectly. Then make sure the battery and charging system are working correctly, and verify battery SOC is greater than 70% before beginning diagnostics. After that, scan all network modules for related system or symptom codes. If other codes are present, check what they mean first. Circuit-related codes come before system or performance type codes, and if several circuit codes are present, look for a common power or ground cause. Now work through the vehicle checks in order. Inspect the wiring harnesses for damage, chafing, and correct routing. Check fuses, circuits, and connectors for continuity and correct installation, and make sure the related components are actually connected. For a lean complaint, do not skip the air side. Inspect vacuum lines and the air intake system for leaks, routing problems, or restrictions. Check hoses for damage, leaks, blockage, and routing. Then check fuel quality, including octane, contamination, and winter or summer blend. Inspect the fuel system, including the tank and lines, for damage, leaks, and routing. Continue with coolant level and quality with the engine at the correct operating temperature. Check oil level and quality for contamination and maintenance condition, and inspect the exhaust for damage, restrictions, and routing problems. When you connect test equipment or jumper wires at terminals, use Rotunda Flex Probes NUD 105R025F or Terminal Probe Kit 418S035 so you do not damage pins. Check male to female terminal fit with the mating pin and feel for normal separation force. If connector hardware is adding drag and you need to check a small pin correctly, remove the pin from the hardshell, pin guide, or retainer for that test. If the connector, pin, or terminal is damaged, replace the damaged connector part. Then use the scan tool to read PID input values, output states, and diagnostic states, and use the data logger when you need a more accurate look without unnecessary disassembly. Before blaming a module, understand how the module function is supposed to work, make sure programmable parameters are set correctly, resolve directed DTCs first, test hardwired and networked inputs, test outputs, and check for software updates. If you use output state control to switch a component, use it to confirm the module can turn the output on and off. Do not apply power or ground directly to module-switched components with jumper wires unless that exact test calls for it. When you get into circuit testing, do not rely only on voltage with the intended load disconnected unless you are only trying to find an open. For power-providing circuits carrying approximately 200 to 1000 milliamps, load the circuit with a 250 to 350 milliamp test light and measure voltage with the test light connected. If voltage drops during that loaded test, suspect excessive circuit resistance. As a conductor size guide, 24 gauge or smaller conductors are generally used to carry approximately 1000 milliamps or less, and 20 gauge or larger conductors are generally used to carry 1 ampere or more. For circuits carrying more than 1 ampere, load the circuit with a similar current device, such as a brake light bulb. Again, voltage reduction during loading points toward excessive resistance. For higher current circuits, voltage drop is the better test. Check grounds by measuring voltage drop while the component is operating or trying to operate. Use an ohmmeter on ground circuits only after the battery has been disconnected, because voltage in the circuit will corrupt the reading. For most small diameter ground wires, 18 gauge and smaller, expect less than 2 ohms, and for most wiring harness circuits, expect less than 2 ohms. A standard DMM ohm meter's low resistance resolution, approximately 0.1 ohm, limits its accurate use to circuits carrying less than approximately 5 amperes. If resistance changes when you reverse the DMM leads, the result is not valid unless the circuit contains a semiconductor. To check for unintended continuity to ground or to another unpowered circuit, disconnect both ends and expect resistance greater than 10,000 ohms. To check for unintended continuity to a powered circuit, disconnect both ends, turn on ignition or run power, and verify no voltage is present. Back probing is only for cases where the circuit has to be tested under actual operating conditions, especially for voltage drop analysis. Treat it as a risky method. Use proper back probes. Do not force test leads into connectors. And remember that a poor probe connection can fool you. Voltage drop tests should show a small amount of voltage, expected to be less than 5% of circuit operating voltage.
Do not use back probing as a single-point voltage check when 0 volts is a possible result. Disconnect the circuit and test normally. Do not use back probing for continuity or open circuit checks with an ohm meter between 2 points. Isolate the circuit and test normally.
If jumper wires are used, always use fused jumper wires. The recommended universal testing jumper wire fuse is 5 amperes or less, unless the load requires a larger fuse rating. Use flex probes or equivalent to protect terminals, but do not use flex probes to carry high current greater than 5 amperes. Follow the test directions carefully with jumpers, and never repair a circuit by adding a parallel wire until you understand why the original circuit failed. For voltage drop testing, connect the voltmeter at the beginning and end of the suspect circuit and test with the circuit operating or attempting to operate, with power available to flow. Keep meter polarity aligned with conventional current flow. A 0-volt reading during voltage drop testing can mean poor voltmeter connections or that the component has not been turned on. Voltage indications greater than 0.5 volts indicate abnormal voltage loss and point toward high resistance in wires or connectors. For a voltage in, voltage out test, connect the negative meter lead to ground or battery negative and test with the circuit operating. Probe the power side of the load, then the negative side. The power side should be within 0.5 volts of battery voltage, and readings of 0 volts or source voltage point toward an open circuit. Keep the verification separate from the testing. Once you have corrected an identified fault, confirm the original concern, and make sure P0171 does not come right back. If the path stops short of a clear answer, pause, recheck the earlier diagnostic path, and avoid guessing. The takeaway is simple. Prove the concern. Handle circuit and basic system issues first. Inspect the air, fuel, fluid, and exhaust basics in order, and do not guess at parts. For more diagnostic training, visit stepdiagnostics.com.